Welcome to the Faraday's Law Lab. In part 1 of this experiment, we will be measuring the voltage induced by a swinging coil through a magnetic field.
Mount the rotary motion sensor near the end of the metal rod. Screw the pendulum to the rotary motion sensor such that it's free to rotate. You may need to hold the pulley while doing this. Adjust the height of the metal bar such that the coil swings through the center of the magnet.
Plug the rotary motion sensor into digital channels 1 and 2 of the data acquisition interface. Plug the voltage sensor leads into the terminals of the pendulum and also into analog channel A. Plug the magnetic field sensor into analog channel B.
Ensure the magnetic field sensor is set to radial and a range of 1x. Open the Data Studio file called Induced EMF. Press Start and zero the magnetic field sensor by holding it away from any magnetic sources and pressing the tare button. Hold the magnetic field sensor between the magnet poles, paying attention to its orientation so that you measure the horizontal magnetic field.
Arrange the cables so that they don't interfere with the pendulum swing. You may wish to hold the voltage sensor leads during data collection. Press Start on Data Studio. Lift the pendulum to an angle of around 25 degrees and release it. Stop data collection after the pendulum has swung through the magnet.
In part 2 of this experiment, we'll be measuring the energy dissipated in a resistor attached to the coil that is swung through a magnetic field, accounting for frictional losses in the pendulum.
Close the Data Studio file and open the one called Induction Energy.
Remove the voltage sensor leads and measure the resistance of the coil using a multimeter. Note that the coil may cause the resistance reading to fluctuate, and you may have to estimate the average reading. Also, measure the resistance of the resistor.
In Data Studio, click Calculate and adjust the power formula by clicking the drop-down arrow and selecting it. Change the resistances to what you measured and click Accept.
Remove the pendulum from the rotary motion sensor. Rest it on the edge of a table and move its position until it starts to fall in order to find its center of mass. Measure the distance from this point to the pivot point.
As before, enter this distance into the potential energy equation in Data Studio's calculator.
Return the pendulum to the rotary motion sensor and attach the resistor to one terminal only, with the voltage sensor leads connected to it.
Due to an issue with the rotary motion sensors, you will need to complete a quick test. Press Start on Data Studio, set the pendulum in motion, and observe the angular position versus time graph. If the graph does not oscillate around 0, as you can see here, you will need to make some adjustments.
To fix this, click Setup and lower the sample rate. Again, press Start, start the pendulum moving, and check if the angular position oscillates around 0. If it does, you may proceed.
Move the angular position display so that it's visible. Press Start and carefully lift the pendulum to 25 degrees. Release it and stop data collection after it reaches its highest point. You should repeat this measurement at least 10 times and take the average.
Connect the resistor across both terminals and repeat the process. As before, press Start and carefully lift the pendulum to 25 degrees. Release it and stop data collection after it reaches its highest point. Again, you should repeat this measurement at least 10 times and take the average.
Thanks for watching the Faraday's Law experiment. And remember, if you don't have enough energy to write your lab report, try swinging yourself through a magnetic field.